In this video, we're going to take the derivatives of natural logarithms. So we have to remind ourselves that a natural logarithm, as written here, is really just this. Y is equal to log base e with the argument x. We can convert that function into exponential form by saying that e to the y is equal to x. That's what this equation is saying. Now it says differentiate the above exponential function with respect to x. Well, if I look at the left side right here, I'll just rewrite the exponential function here. If I look at the left side, I can't differentiate that with respect to x because it's in terms of y. So what I'll first do is I'll say d dy of e to the y, and then I'll chain that with dy dx. And then on the right side over here, I have d dx, so the derivative of just x. I'm just going to move this over so that it's in line with the equal sign right here. Okay. All right, there we go. Okay, so if I look at this right here, I recall that taking the derivative of the exponential function with base e simply returns the original function. So I have e to the power of y. I still have dy dx, and then the derivative of x with respect to x is simply just 1. I need to isolate for dy dx, so I'm going to bring the e to the y over to the other side. And I do that by dividing both sides by e to the y. And now that I have this, I recall that I've previously defined e to the y as x. So I can actually rewrite this as dy dx is simply equal to 1 over x. So the conclusion that we come to right here is that the derivative of the natural logarithm, so y is equal to ln x, is simply 1 over the argument. All right. Now, if the argument is in of itself a function, we'll have to use the chain rule. And we're going to see that right here. Y is equal to ln 2x plus 1. This is a composite function. It's a composite function of the natural logarithm function, and then also the argument is a linear function. So I have what's called like an outside function right here, and I also have an inside function, which is my linear function, right? So to take the derivative, we first find the derivative of the outside function, and I know that the derivative of the natural logarithm function is just 1 over the argument, so I go 1 over 2x plus 1, and then I have to then chain that with the derivative of the inside function, which is this linear function 2x plus 1, and that's just 2. So combining this, I have 2 over 2x plus 1. And there's my derivative. Moving on to the next one, y is equal to x squared plus ln 3x. All right, so here I'm going to use the product rule. All right, so I say y prime is equal to, and I'll color code it, I'm going to say derivative of the first, 2x times the second, ln 3x, plus the first, and then I do the derivative of the second function. And as we can see here, this is again a composite function. It's a composite function of the natural logarithm function, and then the argument, 3x, is a linear function. So I'll take the derivative of the natural logarithm function, and so I say it's 1 over the argument, 3x, and then the derivative of the argument itself is simply 3. You can probably see right here that we have 3's that will cancel. My x's will cancel over here, and this gets reduced to 2, from 2 to 1. So I end up with y prime is equal to 2x ln 3x plus x right here. Okay, recognizing then that I can actually factor out an x from both terms. Y prime is equal to x 2 ln 3x plus 1, and that's my final answer. The next example looks a little bit more complicated than it really is, because in this example right here, we simply have to use our logarithm laws that we had previously learned. So I'm going to simplify this statement a little bit, and I'm going to say that y is equal to ln, and I'm going to say x plus 2 all cubed plus the natural logarithm of 2x minus 3. because if there's multiplication in the argument, then that means we can separate the two factors within the argument into two terms with addition in between and the natural logarithms of those two factors. I also know that the exponent rule of logarithms means that I can bring an exponent on the argument in front as a coefficient. So 3 ln x plus 2 plus ln 2x minus 3. And now I can go ahead and I can find the derivative. So when I find the derivative, I don't have to worry about this 3. This is a constant multiplier, so I'm just going to keep this in front like that. And then the derivative of the natural logarithm is just 1 over the argument. And then the derivative of the argument itself there is just 1, right? Okay. Then over here, I don't have a coefficient, so I can just go ahead and find the derivative of the natural logarithm. That's 1 over the argument. But then the derivative of the argument itself is 2. So my final answer right here is 3 over x plus 2 plus 2 over 2x minus 3. Now what I'm going to do is I'm going to sub x is equal to 4, because that's what the question's asking me to do right here. So then I get y prime is equal to 3 over 4 plus 2 over 2 times 4 minus 3. And then when I go ahead and simplify all this, I'm going to get 3 over 6 plus 2 over 5. Okay. Y prime is 1/2 plus 2 over 5. Y prime is equal to 5 plus 4 all over 10, finding the common denominator. So y prime is equal to 9 over 10 when x is equal to 4. Again, this next example looks far more complicated than it really is. All we have to do here is, again, apply our logarithm laws. So I'm going to go ahead and I'll do this step by step. I'll start with my numerator right here. I've got multiplication in the numerator. So I'm going to say ln x squared plus 3 all raised to the power 4 plus ln 2x cubed plus 6 all raised to the power 5. And then I have to recall that when I am dividing, I subtract a logarithm, so 5 minus 3x all squared. Now I'm going to apply my exponent rules of logarithms, so they're going to become coefficients. Okay. And now I can go ahead, I can easily take the derivative of this now. So the 4 that I see right here is a constant multiplier, so I can just leave that alone. 1 over the argument times the derivative of the argument. 5 times 1 over the argument times the derivative of the argument minus 2, again, 1 over the argument times the derivative of the argument, which is negative 3. So I'll go ahead and I'll clean this up. I'll have 8x all over x squared plus 3, 8x because the 4 times the 2x. Okay, and then the 5 times the 6x squared is going to be 30x squared all over 2x cubed plus 6. And then plus 6 all over 5 minus 3x. Well, you might be able to see here that this can be factored into 2, and then we've got x cubed plus 3. And then the 2 will be able to then cancel with this, bring that down to 15. That goes to 1. So I can then just quickly rewrite this as 8x all over x squared plus 3 plus 15x squared all over x cubed plus 3 plus 6 over 5 minus 3x, and that's my derivative of that natural logarithmic function. Okay, you can see that the homework is included, and thanks again for watching.